Well, the corners are cut off from an equilateral triangle to produce a regular hexagon. Well, what do we mean by an equilateral triangle? Where all the sides and angles are equal, being 60° as each angle. And regular hexagon is the hexagon where all the angles are equal, being 120 of each, and all the sides are also equal. So we need to cut the corners of the triangle so that we can get a regular hexagon. And now the question is, what is the ratio of hexagon area to the triangle, right? Now we don't have to use all the formulas for regular hexagon or whether it is triangle. We just have to imagine how we can divide this triangle into different areas. Now if you look at this triangle, I have already cut down the corners for this triangle. So if I join the opposite corners of this regular hexagon, I may get something good part here, right? So this is a regular hexagon, the middle part, which I've taken out for you guys to understand in a more simpler way. Now, if you look at this diagram carefully, all the triangles are of equal area. Why? Because all the angles of this middle, the smaller triangles are equal, 60°, 60° and 60°. So if these angles are equal, then we get this equilateral triangle. So all the triangles, whichever comes into this hexagon, are equilateral triangle. So naturally, the remaining part, the corners of this triangle will be also equilateral triangle. So we have now all the smaller triangle as equilateral triangle, which has equal areas, of course, right? So we just have to count how many triangles are there in the hexagon and how many triangles are there in a triangle, the bigger triangle. So to get the ratio of regular hexagon to the triangle, all you have to just count the triangles. So in hexagon, we have just 6 equal triangles. So just put, we have total 9 triangles in the larger triangle, right? 9 smaller triangle. So after simplifying, you will get 2:3 as the ratio of area of hexagon to the triangle. And in that case, option A will be your correct answer.